Tonight, you are about to confront something so vast that your mind will quietly resist believing it is real. There exists a galaxy so enormous that if it replaced our own, it would not just surround us. It would consume everything we recognize in the night sky. Entire neighboring galaxies would disappear inside it, as if they had never existed at all. And the strange part is, this cosmic giant is not hypothetical. It is out there right now, silently drifting through the universe. Before we reveal its name, let's sit with the question that makes this so unsettling. How big can a galaxy actually become before the universe itself says enough? Here on Velarin's Sleepy Space Mysteries, we often explore ideas that stretch the limits of imagination. In a recent journey, we followed the quiet pull of supermassive black holes, those invisible anchors shaping entire galaxies. But tonight, we are stepping even further out, into something larger than those anchors themselves. Because this story is not just about a galaxy. It is about scale breaking down, about size losing meaning, and about a structure so immense that even light, the fastest thing that exists, needs millions of years just to cross it. And as we move deeper into this mystery, you may begin to notice something unsettling. The universe does not seem to have a clear limit. If that thought intrigues you, consider subscribing, liking the video, and turning on the bell so you don't miss future journeys into the unknown. And if you feel like supporting the channel more deeply, membership helps keep these quiet explorations alive. Before we continue, tell me softly in the comments, where in the world are you listening from tonight? Let's begin gently with something that seems simple, but quietly holds the key to everything that follows. What exactly is a galaxy? You have heard the word countless times. You know we live inside one. You have seen images, those soft spirals of light, floating in darkness like cosmic whirlpools. But when we slow down and really listen to the meaning, a galaxy becomes something far more mysterious. A galaxy is not just a collection of stars. It is a vast, gravitationally bound system where hundreds of billions, sometimes trillions, of stars drift together in a slow, silent dance. Alongside them are clouds of gas, dust, invisible dark matter, and countless planets, most of which will never be seen. But here is where things begin to feel strange. Unlike a city or a planet or even a solar system, a galaxy does not have a clear edge. There is no boundary you can point to and say, this is where it ends. Instead, galaxies fade, slowly, gradually, almost imperceptibly, into the darkness between them. The stars become more spread out. The light grows thinner until eventually, there is almost nothing at all. And that raises a quiet question. If a galaxy has no true edge, how do we measure its size? This question becomes very important when we begin talking about the largest galaxy ever found, because suddenly, size is no longer a simple number. It becomes an estimate, a blurred boundary, a soft transition between something and nothing. Now let's bring this closer to home. Our own galaxy, the Milky Way, feels unimaginably large to us. It contains somewhere between 200 and 400 billion stars, each one a sun, each one potentially surrounded by its own worlds. If you tried to count them, 1 star per second, you would still be counting long after all of recorded human history had passed. Entire civilizations would rise and fall while you were still counting. And yet, in the grand structure of the universe, the Milky Way is considered average, not small, not large, just typical. It stretches about 100,000 light-years across. That means even light itself, the fastest thing that exists, needs 100,000 years to travel from one side to the other. Pause there for a moment. Light, which moves so fast that it can circle the Earth 7 times in a single second, still takes 100,000 years just to cross our galaxy. Now imagine trying to cross it yourself. Even if you could travel endlessly without rest, at the speed of a car on a highway, it would take longer than the age of the universe many times over just to reach the other side. And yet, everything you have ever known, every star you have ever seen, every constellation in the night sky, exists inside this one structure. Feels complete, feels vast, feels like everything. But this is where the illusion begins to break, because the galaxy we are slowly approaching tonight makes the Milky Way feel almost insignificant, not slightly smaller, not modestly outscaled, but reduced to something closer to a fragment. And this is where the mind begins to struggle, because we are not used to comparing things at this level. Our brains evolved to understand distances between trees, mountains, cities, not structures that stretch across millions of light years. So instead of trying to calculate, we will do something simpler. We will feel the difference. Imagine the Milky Way as a single house. Everything inside it, every star, every planet, every possibility of life, is contained within that house. Now imagine the largest galaxy. It is not another house. It is not even a city. It is something closer to an entire continent. A structure so vast that thousands of galaxies like ours could exist within its reach. And yet, when we look at it from Earth, it does not appear grand. It does not dominate the sky. It does not glow with overwhelming brightness. Instead, it appears as something almost disappointing. A faint, soft smudge of light, barely visible even through powerful telescopes. And that contrast is one of the quiet mysteries we will return to later. How can something so unimaginably large appear so small, so dim, so easily overlooked? For now, just hold on to that question, because in the next step of this journey, we will finally give this cosmic giant a name. And when we do, the scale of what you are about to understand will begin to unfold in a way that is both calming and deeply unsettling. Now, let us gently lift the veil. The galaxy we have been circling, the one that stretches the idea of size beyond anything familiar, is known as IC 1101. At first, the name feels almost underwhelming. It sounds like a catalog entry, something technical, something distant, and in a way that is exactly what it is. For a long time, it was just another faint object recorded by astronomers, a quiet smudge among thousands. But behind that simple label lies something almost incomprehensible. IC 1101 is estimated to be between 4 and 6 million light-years across. Take a moment with that number. Not thousand, not 100,000, millions. Earlier, we said the Milky Way stretches about 100,000 light-years. Already a number so large it becomes abstract. But IC 1101 is not just larger. It is 40 to 60 times larger in diameter. And when something grows in diameter, its volume, its true size, does not just increase a little. It explodes outward. This means IC 1101 is not just dozens of times larger than our galaxy. It is thousands of times more massive in terms of space it occupies. Now let that comparison settle in a quiet way. If the Milky Way feels like a vast ocean of stars, IC 1101 is something closer to an entire cosmic horizon. And yet, even that comparison falls short, because IC 1101 does not just exist alone in emptiness. It exists in a region of space filled with other galaxies, neighbors, companions, entire systems bound together by gravity. So let us imagine something very simple and very unsettling. Imagine taking IC 1101 and placing its center exactly where the center of the Milky Way is right now. No explosions, no violence, just a quiet replacement. What would happen? First, everything in our galaxy would still be there. The sun, the earth, every star you have ever seen. But as you begin to look outward, you would notice something strange. The edge of your galaxy would not be where it used to be. It would keep going and going and going until eventually it would reach beyond the Milky Way entirely. It would stretch past the outer regions into intergalactic space and continue expanding outward until it reached our nearest large neighbor, the Andromeda Galaxy. And then, quietly, it would swallow it, not collide in a dramatic sense, not explode, simply absorb. Andromeda, which already feels distant and separate to us, would just become another region inside the same galaxy. And even then, IC 1101 would not be finished. It would continue outward, reaching other nearby galaxies, smaller companions, distant members of what we call our local group. One by one, they would all fall within its enormous reach. What we currently think of as a collection of separate galaxies would instead become one single structure, a single continuous system of stars. This is the scale we are dealing with. And yet, here is where things become even more subtle and more mysterious. Because despite this immense size, IC 1101 is not sharply defined. Remember earlier when we spoke about how galaxies fade rather than end? With IC 1101, that fading becomes even more extreme. Its outer regions are so diffuse, so spread out, that astronomers still debate exactly where the galaxy truly ends. Different methods of measurement give slightly different sizes. Some define its boundary based on brightness, others based on the motion of stars, others based on gravitational influence. And depending on how you choose to measure it, the galaxy can appear larger or slightly smaller. So even the number 4 to 6 million light-years is not a precise boundary. It is more like a soft estimate of something that refuses to have a clear edge. And there is something quietly poetic about that. The largest galaxy we know is also one of the least clearly defined, as if the universe itself is reminding us that at the largest scales, precision begins to dissolve. Now, let us step back for a moment and consider something even more subtle. If I see 1101 is so enormous, why did it take us so long to recognize it? Why is it not something everyone talks about? The way we talk about black holes or supernovas, the answer lies in something surprisingly simple: distance. I see 1101 is located about 1 billion light-years away from us, which means the light we see from it tonight began its journey 1 billion years ago, before animals walked on land, before plants covered the continents, before even complex life had truly begun to flourish. What we are seeing is not the galaxy as it is now. It is the galaxy as it was in a distant ancient chapter of the universe. And because of that distance, something very strange happens. Even though IC 1101 is unimaginably large, it appears incredibly small, just a faint, soft glow against the darkness, almost invisible. And so, for centuries, it remained unnoticed for what it truly was, a giant hiding in plain sight. And this leads us gently into the next mystery. If IC 1101 did not begin this large, then how did it become this way? What kind of process could build something so vast over time? And more importantly, is it still growing even now? Let's move a little deeper now, not into distance, but into time. Because to understand something as vast as IC 1101, we cannot just ask how big it is. We have to ask how long it has been becoming. Nothing in the universe begins at its final size. Not stars, not planets, not galaxies. Everything grows slowly, quietly, over immense stretches of time. And IC 1101 may be one of the most extreme examples of that process. When we look at it, we are seeing a galaxy that has had nearly the entire age of the universe to evolve. Billions upon billions of years of motion, of gravity, of silent interaction. And in that time, something very important has been happening. Galaxies do not live alone. Even though space feels empty, galaxies are constantly moving, drifting through vast gravitational landscapes shaped by both visible matter and something far more mysterious, dark matter. These invisible structures guide the motion of galaxies like currents in a slow cosmic ocean. And when galaxies drift too close to one another, something inevitable begins. First, it is gentle, a slight pull, a subtle distortion. Stars begin to shift, gas clouds stretch, long, faint streams of material are pulled outward, forming delicate arcs that extend into space. This is not destruction, it is interaction. two galaxies beginning to feel each other's presence. If they continue to move closer, the interaction deepens. Their shapes distort further. Their internal structures begin to lose their symmetry. Regions of gas compress, triggering waves of new star formation, brief bursts of light in an otherwise quiet system. And then, if the conditions are right, they merge, not in a sudden crash, but in a slow, intricate dance that can last hundreds of millions of years. They pass through each other separate and return again, each time losing a little energy, each time becoming more bound together. Eventually, they can no longer escape, and what was once two galaxies becomes one. Now imagine this process not once, but again and again and again, over billions of years. This is how galaxies grow. And in the case of IC 1101, this process did not happen occasionally. It happened relentlessly. IC 1101 sits at the center of a massive galaxy cluster, a region of space filled with thousands of other galaxies. This environment is not quiet. It is dense, dynamic, full of motion. And at the center of this environment, gravity favors one thing. The largest object becomes larger, because as smaller galaxies move through the cluster, they are gradually pulled inward. Their motion slows, their paths curve gently, but inevitably toward the center. And waiting there is IC 1101. Over time, smaller galaxies drift too close and are captured. Their stars are stripped away, their structure dissolves, and their material becomes part of the larger whole. Astronomers sometimes call this process galactic cannibalism. It sounds dramatic, but in reality, it is quiet. There are no explosions you would see with your eyes, no sudden flashes, just a gradual absorption, a blending of stars into a larger system. And each time this happens, IC 1101 grows, its halo expands, its mass increases, its gravitational pull becomes stronger, which makes it even more effective at drawing in the next galaxy. This creates a kind of feedback loop. The bigger it becomes, the faster it can grow. But here is something subtle and important. Each merger does not just add size. It changes the galaxy itself. Spiral galaxies, like the Milky Way, have structure. They have arms, rotation, order. But when galaxies merge repeatedly, that order breaks down. The neat rotation becomes chaotic. Stars move in more random directions. The elegant spiral arms disappear. What remains is something smoother, rounder, more diffuse, an elliptical galaxy. And IC 1101 is exactly that, a giant elliptical system built from the remnants of countless smaller galaxies that no longer exist as separate entities. And if you could somehow trace every star in IC 1101 back through time, you would find that many of them were not born there. They came from elsewhere, from galaxies that were slowly and quietly consumed. Now, remember something we touched on earlier. The edges of a galaxy are not clearly defined. In IC 1101, this becomes even more meaningful, because its outer halo, the faint region extending far beyond its core, is made largely of these captured stars. Stars that once belonged to other galaxies, now drifting in a vast, shared space, their origins blurred by time. Over billions of years, the evidence of these mergers fades. The streams, the structures, the remnants, all slowly dissolve into a smooth distribution. And today, IC 1101 appears calm, stable, almost timeless. But that calm surface hides a long history of growth, of interaction, of quiet accumulation. And it raises a question that lingers softly in the background. If this galaxy became so enormous by consuming others, then what happens when there are fewer galaxies left to consume? Does the growth slow down? Does it stop? Or is IC 1101 still, even now, expanding its reach, one quiet merger at a time? We will explore that as we move closer to the heart of this giant, because at its center, something even more extraordinary is waiting. Now, as we continue drifting inward toward the deeper nature of this galaxy, there is something we need to understand, because size alone is not what makes IC 1101 so unusual. It is what that size represents after everything has already happened. You see, galaxies like the Milky Way are still alive in a very specific way. They are still forming new stars. Deep within their spiral arms, clouds of gas collapse, ignite, and give birth to new suns. It is an ongoing process, a quiet but continuous. But IC 1101 is different. It is what astronomers sometimes describe in a strangely poetic way as red and dead. That does not mean it is gone. It does not mean it is empty. In fact, it contains more stars than we can truly comprehend. But it means something else. It means that most of its star formation has already ended. Long ago, during those countless mergers we just explored, something important happened to the raw material needed to create new stars. Gas. In younger galaxies, gas exists in large, cold clouds. These clouds can collapse under gravity, forming new stars over time. But when galaxies merge, especially again and again, that gas is disturbed. Some of it is compressed suddenly, creating brief bursts of star formation that burn through the available material very quickly. Other portions are heated, or even pushed out of the galaxy entirely, escaping into intergalactic space. Over time, the galaxy loses its ability to create new stars, and what remains is a population of older stars, cooler stars, redder stars, stars that will continue to shine for billions, even trillions of years, but will not be replaced once they fade. This is why IC 1101 glows with a soft yellow-red light. Not bright blue, not energetic, not youthful, but calm, aging, quiet. It is a galaxy that has already lived through its most active period and is now slowly, gently evolving towards stillness. And there is something almost peaceful about that, but also something deeply humbling, because when we look at IC 1101, we are not just seeing size. We are seeing time, We are seeing the result of billions of years of activity, now settling into a kind of cosmic silence. Now, let's return briefly to something we mentioned earlier, a question that may still be lingering. If IC 1101 is so massive, why does it not appear overwhelming in the sky? Why does it not shine like a beacon, easily visible to anyone who looks up? The answer lies in something subtle but powerful: surface brightness. Imagine spreading the light of trillions of stars across a region millions of light years wide. Each small portion of that galaxy only contributes a tiny fraction of the total light. So even though the galaxy as a whole is incredibly luminous, any given point within it appears faint. It is like taking a bright light and stretching it thin across an enormous space. The result is something vast, but dim. And when you combine that with its distance, 1 billion light years, the effect becomes even more extreme. By the time its light reaches us, it has spread out, weakened, and softened. What remains is just a faint glow, a whisper of light carrying the story of a galaxy that has existed for nearly the entire history of the universe. And that is why IC 1101 remained just another catalog entry for so long. Not because it was small, but because it was too vast and too distant to stand out. There is something quietly ironic in that. The largest galaxy we know is one of the hardest to truly see. Now, let us take one more step inward, because everything we have explored so far, the size, the mergers, the aging stars, all of it leads to a single point: the center. Every large galaxy, no matter how diffuse, no matter how ancient, tends to hold something at its core. Something that shapes its structure, influences its motion, and quietly governs its evolution. In the Milky Way, that central presence is a supermassive black hole, a region where gravity is so intense that nothing, not even light, can escape once it passes a certain boundary. And if that exists in our galaxy, then what must exist at the center of something like IC 1101? A galaxy tens of times larger, containing trillions of stars, built from the remnants of countless others. What kind of object could sit at the heart of something so immense? And how powerful would it have to be to influence a structure of this scale? As we move into the next part, we will finally approach that center. And what we find there will not just match the scale of the galaxy. It may exceed it in ways that are difficult to fully grasp. Now we move closer, not across distance, but inward toward the center of something so vast that even its core feels like a separate universe of its own. Because at the heart of IC 1101, there is not emptiness, there is not silence, there is something waiting, and to understand it, we must first gently return to a familiar idea. In almost every large galaxy we have studied, there exists a central presence, something invisible yet undeniable, something that does not shine, yet shapes everything around it, a supermassive black hole. In our own galaxy, the Milky Way, this central object is already difficult to comprehend. It contains about 4 million times the mass of our Sun. A dense, compact region, quietly holding the inner structure of the galaxy together. Stars near it move at incredible speeds, pulled into tight orbits by its gravity. And yet, compared to what lies at the center of IC 1101, that black hole feels almost small. Because the black hole inside IC 1101 is not just larger. It belongs to an entirely different scale. Estimates suggest it contains tens of billions of times the mass of our Sun. Some measurements place it around 60 billion solar masses, though even that number may shift as our understanding improves. Now, instead of trying to calculate that difference, let's feel it. If the black hole in the Milky Way were a single grain of sand, then the one in IC 1101 would be something closer to a mountain. Not just bigger, but fundamentally more overwhelming. And like all black holes, it is defined by something known as the event horizon. This is the boundary beyond which nothing can return. Once anything, light, matter, even information, crosses this threshold, it is gone from the visible universe forever. For a black hole this massive, that boundary becomes enormous, so large that if you placed it at the center of our solar system, its reach would extend far beyond the orbit of the outer planets. Everything we know, every planet, every orbit would exist inside that boundary, already beyond escape, and yet, even that description only hints at its presence. Because a black hole is not just defined by what falls into it, it is also defined by what happens around it. As matter drifts toward the black hole, it does not simply disappear immediately. Instead, it forms a slowly rotating disk, spiraling inward over time. Friction within this disk heats the material to extreme temperatures, causing it to glow across multiple forms of light: visible, X-ray, radio. From a distance, this creates the illusion of something active, something almost alive. And in some cases, powerful jets of energy are launched outward from the regions near the black hole's poles, streams of particles traveling at nearly the speed of light, extending across vast distances. These jets can influence entire regions of space, heating surrounding gas, shaping the environment of the galaxy itself. In IC 1101, evidence suggests that such processes are happening. Even now, quietly, continuously, the black hole at its center is not violently consuming everything in sight, but it is still active, still drawing in material, still releasing energy, still shaping the galaxy around it. And here, something fascinating begins to emerge. There appears to be a deep connection between a galaxy and its central black hole. The larger the galaxy, the larger the black hole. The more mass the galaxy contains, the more massive the black hole becomes. It is almost as if they grow together, evolving side by side over billions of years. And when galaxies merge, as IC 1101 has done many times, their central black holes do not remain separate. They move toward each other, slowly drawn together by gravity, until eventually they merge as well, each merger adding to the mass of the central object. Each event making it larger, more powerful, more dominant. So when we look at the black hole in IC 1101, we are not just seeing a single object. We are seeing the result of countless past galaxies, countless central black holes, now combined into one. A layered history compressed into a single point in space. And yet, there is something even more subtle happening, because while this black hole is enormous, it is not consuming the galaxy in any immediate sense. It is not pulling everything inward in a dramatic collapse. Instead, it exists in balance. Stars orbit it. Gas flows around it. The galaxy remains stable, even with such an immense gravitational presence at its core. This balance is what allows IC 1101 to exist as it does. A giant structure quietly held together by forces both visible and invisible. But there is still something we have not fully explored, because the black hole is not the only invisible influence shaping this galaxy. There is something else, something far more diffuse, far more mysterious, and far more dominant in terms of total mass. Something that does not emit light at all. And yet, without it, IC 1101 would not exist in its current form. As we continue, we will step beyond stars, beyond black holes, and into the hidden structure that holds entire galaxy clusters together. A structure that you cannot see, but whose presence is everywhere. Now, let us move even deeper, because if you could somehow step back far enough to see IC 1101 not as a single galaxy, but as part of something larger, you would begin to notice a hidden structure. A structure that does not shine. A structure that does not glow. And yet, it is the reason everything stays together. This structure is known as dark matter. And to understand IC 1101 fully, we have to accept something quietly unsettling. Most of what holds this galaxy, and the entire cluster around it together, is invisible. When astronomers observe galaxies, they quickly notice something strange. The stars inside them move too fast, much faster than they should. If only visible matter were present. By all normal calculations, galaxies should fly apart. Stars should drift away into the darkness. But they don't. Something unseen is holding them in place. Something with gravity, but no light. And this becomes even more dramatic when we look at galaxy clusters like the one IC 1101 lives in. This cluster, known as Able 2029, contains not just dozens, but thousands of galaxies, all moving, all orbiting, all bound together in a vast gravitational system. If we calculate the mass needed to keep this structure stable, the visible matter, the stars, the gas, everything we can detect, accounts for only a small fraction of what is required. The rest is missing, or rather unseen. And so, astronomers describe it as dark matter. Not because it is literally dark in the way we think of darkness, but because it does not interact with light at all. Cannot be seen directly, only inferred through its effects. Now imagine this, surrounding IC 1101 and extending far beyond it is an enormous halo of this dark matter, a vast, invisible structure stretching across millions of light years, forming a kind of gravitational foundation. The stars you see, the faint glow of the galaxy, all of it exists inside this hidden framework, like dust suspended in a transparent sphere. And without this structure, nothing would hold together. The galaxy would not form. The cluster would not exist. Everything would slowly drift apart into emptiness. So in a very real sense, IC 1101 is not just made of stars. It is built upon something we cannot see, something we still do not fully understand. And yet, its presence is undeniable. Now, let us gently connect this back to something we explored earlier. Remember how IC 1101 grew by merging with other galaxies. Each of those galaxies also carried its own dark matter halo. And when they merged, those halos merged as well. Layer upon layer, accumulation upon accumulation, building a larger and larger invisible structure. Over billions of years, this created a massive gravitational well at the center of the cluster. And what happens in any system governed by gravity is very simple. Everything falls inward, slowly, inevitably. So as galaxies moved through the cluster, they were gradually pulled toward this central region, toward IC 1101. This is why it sits exactly where it does, not by chance, but because over time gravity guided it there. Or perhaps more accurately, it became the center because it grew large enough to dominate everything around it. And once it reached that position, its growth accelerated. More galaxies passed nearby. More were captured. More were absorbed, until IC 1101 became what astronomers call the brightest cluster galaxy, the dominant presence, the central giant. But there is something else happening here, something more subtle. The space between galaxies in a cluster is not empty. It is filled with extremely hot gas, heated to temperatures so high that it emits X-rays instead of visible light. This gas forms a vast, diffuse cloud surrounding all the galaxies in the cluster. And interestingly, it behaves in a way that reveals the underlying structure of dark matter, because the gas settles into the gravitational field, tracing its shape. So by observing this glowing X-ray gas, astronomers can map the invisible. They can see where dark matter must be based on how the gas is distributed. And what they find is remarkable. The density of dark matter increases smoothly all the way toward the center, toward IC 1101. There is no sudden boundary, no sharp edge, just a continuous rise deeper and deeper into the gravitational well, which tells us something profound. IC 1101 is not just large. It sits at the deepest point of an enormous cosmic structure, a place where gravity has been quietly pulling matter inward for billions of years. And this brings us back to a question we left open earlier. Is IC 1101 still growing? The answer is both simple and complex. Yes, but much more slowly now. In the early universe, there were many more galaxies nearby, many more opportunities for mergers. Growth was rapid, frequent, almost inevitable. But today, after billions of years of accumulation, there are fewer galaxies left to consume. The environment has become quieter, more stable, and so IC 1101 has entered a different phase. Not one of rapid expansion, but one of slow, gradual evolution. A giant, no longer growing quickly, but still carrying the memory of everything it has absorbed, and perhaps still waiting for the next galaxy that drifts just a little too close. In the next step, we will widen our view once more, because to truly understand IC 1101, we must compare it, not just to our galaxy, but to the other giants of the universe, and only then will its scale feel fully real. Now, let us gently widen our view again, because sometimes the only way to truly understand something extraordinary is to place it beside something familiar. So instead of looking at IC 1101 alone, we will compare it to galaxies we already know. And as we do, something subtle begins to happen. Scale starts to shift. Let's begin with our closest large neighbor, the Andromeda Galaxy. Andromeda is often described as massive, contains around 1 trillion stars, several times more than the Milky Way. It stretches roughly 200,000 light-years across, making it one of the largest galaxies in our local region. It is so large that on a dark night far from city lights, you can actually see it with your own eyes. Just a faint, soft glow, but visible. And for many people, Andromeda represents the idea of a giant galaxy. But now, let's place it next to IC 1101. Suddenly, Andromeda begins to feel smaller, not because it has changed, but because our reference point has. IC 1101 is not just twice as large. It is roughly 20 times larger in diameter. And again, when diameter increases, the true scale grows far beyond that. This means IC 1101 could contain not just one Andromeda, but many spread across its vast structure. Now let's take another step. There is a galaxy known as Messier 87, often simply called M87. It is a giant elliptical galaxy at the center of the Virgo cluster. It has become famous in recent years because it was the first galaxy whose central black hole was directly imaged. M87 is enormous by most standards. It spans about 240,000 light-years and contains trillions of stars. Its central black hole alone has billions of times the mass of our Sun. It is, by any measure, a cosmic giant. And yet, when placed beside IC 1101, even M87 begins to feel limited. IC 1101 is still many times larger, more extended, more diffuse, more dominant. It belongs to a category that is not just big, it is extreme. And now, something interesting begins to emerge, because when we compare galaxies like this, we start to see a pattern. Galaxies do not all grow the same way. Some remain relatively isolated, evolving slowly, forming stars, maintaining their structure. Others exist in dense environments where interactions are constant, where mergers are frequent, where growth becomes accelerated. IC 1101 belongs to this second category. It is not just large because it formed that way. It is large because of where it lives, at the center of a massive galaxy cluster where gravity continuously feeds it new material. And this leads to a deeper realization. IC 1101 is not just a galaxy. It is the outcome of an environment, a product of its surroundings shaped by billions of years of interaction. And that raises a quiet question. If we were to take IC 1101 and place it somewhere else in the universe, far from a dense cluster, would it ever have become this large? Or is its existence dependent on the very specific conditions of its location? This question is still being explored, because while IC 1101 is one of the largest galaxies we have found, it may not be unique. There may be others, hidden at even greater distances, beyond what we can currently observe clearly. Galaxies that are just as large, or perhaps even larger, but because of distance, because of faintness, because of the limits of our instruments, they remain undiscovered. And this brings us back to something we touched on earlier. The universe does not present its largest structures in obvious ways. The biggest things are often the hardest to see, not because they are rare, but because they are subtle, diffuse, spread out across immense distances, their light diluted, their presence softened. So instead of appearing as bright, dramatic objects, they hide as faint glows easily overlooked. And IC 1101 is a perfect example of this. A structure large enough to reshape our understanding of scale, appearing as nothing more than a dim patch of light. Now, let's take one final step in this comparison. Imagine shrinking IC 1101 down so that it fits comfortably within your field of view. Imagine being able to see its full structure clearly, its full extent, its entire halo. What you would see would not be a compact object, not a bright center with defined edges, but something vast, soft, and fading. A galaxy that does not end, but dissolves into space. And within that, trillions of stars moving quietly, each one carrying its own history, each one part of something so large that even the concept of belonging becomes abstract. And this is where the realization settles in. IC 1101 is not just bigger than other galaxies. It exists at the edge of what we can meaningfully describe, a structure so large that our usual ways of thinking begin to lose clarity. And yet, it is real. It exists, and somewhere within it, countless stars are still shining, just as our sun does, unaware of the scale they are part of. In the next segment, we will move toward the final layer of this journey, because beyond size, beyond structure, beyond comparison, there is a deeper question waiting. What does something like IC 1101 actually mean for our understanding of the universe? Now, we arrive at a quieter place in this journey, not at the edge of the galaxy, not at its center, but somewhere in between, where understanding begins to shift into reflection. Because by now, you can feel it. IC 1101 is not just large. It is something that quietly challenges the way we think about existence itself. We often imagine the universe as a collection of objects, stars, planets, galaxies, each with its own identity, separate, defined, understandable. But IC 1101 begins to blur those boundaries. It is so vast, so diffuse, so extended, that it becomes difficult to say where it truly begins and where it truly ends. And in that sense, it feels less like an object and more like a region, a slow transition from structure into emptiness. And within that region, something extraordinary exists. Not just trillions of stars, but trillions of possibilities. Because around many of those stars, there are likely planets, worlds, some hot, some frozen, some drifting alone in darkness, and perhaps a small fraction existing in quiet balance, where conditions allow something more. Liquid water, complex chemistry, the slow emergence of life. Now imagine that, across this one galaxy alone, there could be hundreds of trillions of planets, each one with its own history, its own surface, its own sky. Some may have oceans that reflect distant stars. Some may have atmospheres glowing faintly in alien colors. And on some of them, perhaps, something is watching the sky, something wondering. The same question we are we alone? But here is where time returns gently to reshape that idea. IC 1101 is 1 billion light years away, which means any light traveling between us takes 1 billion years to arrive. So if there were observers on a distant world within that galaxy looking toward us, they would not see Earth as it is now. They would see something ancient, a planet covered in simple life. No cities, no lights, no signs of intelligence. And in the same way, when we look at IC 1101, we are not seeing it as it exists today. We are seeing it as it was long before our species existed. So even in observation, there is a separation, a delay, a quiet disconnect between what is and what can be known. And this introduces a deeper kind of mystery, not just about size or structure, but about perspective. Everything we see in the universe is already in the past. Even the nearest stars appear to us as they were years ago. Galaxies, millions, billions of years ago. So when we say IC 1101 is the largest galaxy we have found, what we really mean is it is the largest in the universe we can currently see, as it once was. And beyond that, there may be more, larger structures, more extreme systems, hidden not because they are rare, but because their light has not yet reached us, or because it has faded beyond what we can detect. And this brings us gently back to something we asked earlier. Is IC 1101 truly the largest galaxy, or simply the largest we have discovered so far? The answer remains open, because our tools are still improving. Telescopes are becoming more sensitive. more precise, able to detect fainter light from greater distances. And with each new observation, the universe reveals something unexpected, something larger, something older, something that quietly reshapes our understanding once again. So it is entirely possible that somewhere beyond our current reach, there are galaxies even larger than IC 1101, structures that would make even this giant seem modest. And if that is true, then IC 1101 is not the endpoint. It is a glimpse, a hint of what the universe is capable of. And that idea carries a certain calmness with it, because it reminds us that no matter how far we explore, there is always more space, more time, more mystery. Now, as we prepare to move into the final part, let's hold on to one last thought. Everything we have explored, size, growth, black holes, dark matter, time, it all connects back to a single realization. The universe does not operate on scales that are meant to be fully understood. It operates on scales that can only be experienced slowly, gently, piece by piece. And IC 1101 is one of those pieces, a quiet giant waiting in the darkness, reminding us how small our familiar world truly is. In the final part, we will let this journey slow down and gently come to rest. Now we begin to slow down, not because the story is ending, but because the scale we've been traveling through asks for something quieter. Because after everything we've explored, the size, the mergers, the hidden structure, the black hole, there is one final layer to understand. Not about IC 1101 itself, but about what it quietly reveals. When we first began, this galaxy felt like an object, something distant, something we could describe, measure, compare. But now it feels different. It feels less like something separate and more like part of a continuous fabric. Because when a galaxy becomes this large, it stops being just a collection of stars. It becomes an environment, a place where entire systems exist within something even greater. And within IC 1101, there are not just stars, but histories. Each star formed at a different time, in a different region, sometimes in a completely different galaxy, before being drawn into this one. So what we are really looking at is not a single story, but the merging of countless stories layered together over billions of years. And yet, all of that complexity appears to us as something simple, a faint glow, a soft blur, a quiet presence in the darkness. There is something almost humbling in that something so vast, so rich in detail, can appear so minimal from a distance. And it reminds us of something important. Perspective changes everything. From within a galaxy, everything feels immense. From outside, it becomes a point of light. And from even farther away, perhaps even that disappears. Now, let's return briefly to the idea of time, because this is where the story becomes almost dreamlike. The light from IC 1101 has been traveling toward us for 1 billion years. which means during that entire time, the galaxy itself has continued to evolve. Stars have aged, some have died, others have shifted in their orbits. Perhaps new interactions have occurred. Perhaps new galaxies have merged with it. But we do not see any of that. We see only the past, a snapshot frozen in time. And this creates a quiet distance, not just in space, but in understanding. We are always looking backward, always observing what has already happened. And yet, from that, we build our understanding of what is. So when we imagine IC 1101 now, in the present moment, we are imagining something we cannot directly observe. We are reconstructing it from light that left long ago. And there is something almost poetic in that even our knowledge is shaped by delay, by distance, by time. Now, let's bring this back to something more personal. When you look up at the night sky, you see stars, points of light, some brighter, some dimmer, and it feels quiet, still. But now, you know, that somewhere among those distant points, there are structures like IC 1101, galaxies so vast, they could contain entire clusters. Galaxies that have grown slowly, patiently, over billions of years. Galaxies that are no longer forming new stars, but quietly holding onto the ones they have. And perhaps, somewhere within them, there are worlds, silent, distant, unaware of us, just as we are unaware of them. And this brings us to a final reflection, not about size or distance, but about place, because it is easy to feel small in a universe like this, to feel like everything we know is just a tiny fragment in something far too large to fully grasp. But there is another way to see it, not as insignificance, but as connection, because the same processes that built IC 1101, gravity, time, the formation of stars, are the same processes that shaped our galaxy, the same processes that led to the formation of our sun, the same processes that allowed Earth to exist. So in a quiet way, we are not separate from these vast structures. We are part of the same unfolding story, just at a different scale. And perhaps that is what makes this so calming. Not that the universe is small, but that it is consistent. From the smallest star to the largest galaxy, the same rules apply, the same forces act, the same slow passage of time shapes everything. And in that, there is a kind of quiet unity. Now, as we continue, we will let the pace slow even further, because the final moments of this journey are not about learning something new. They are about letting everything settle. Now, let everything begin to soften. There is no need to hold on to numbers anymore. No need to compare distances or calculate sizes, because what remains is not the measurement of IC 1101, but the feeling of it, a galaxy so vast that even when we describe it carefully, it still escapes complete understanding. And perhaps that is not a limitation. Perhaps that is the point. because there is something quietly different about encountering something that cannot be fully grasped. It slows us down. It asks us not to solve, but to experience. So imagine this: somewhere 1 billion light years away, IC 1101 continues to exist, not as an idea, not as a measurement, but as a real place filled with stars drifting slowly through the dark. Its outer edges fading so gently that they blend into the surrounding universe. Its inner regions holding ancient stars, each one carrying a story that began billions of years ago. And at its center, that immense black hole, quietly anchoring everything, not with violence, but with presence. Nothing about it is rushed. Nothing about it is urgent. Everything unfolds slowly across timescales so vast that change becomes almost invisible. And yet change is always happening. Stars are aging, their light gradually shifting. Some are reaching the ends of their lives, fading into quiet remnants. Others, still burning steadily, continuing a process that began long before Earth existed. And far beyond them, in the faint outer halo, stars that once belonged to other galaxies continue their silent orbits. They no longer remember where they came from. They are simply part of something larger now. And that idea feels strangely familiar, because in a quiet way, it reflects something about us. We are also part of something larger, not on the same scale, not across the same distances, but within our own world, our own time, our own story. And just like those stars, we move, we change, we become part of systems that existed before us and will continue after. Now, let's return one last time to the idea of light, because everything we have seen, everything we know about IC 1101 has come to us through light that has traveled for 1 billion years. That light began its journey when Earth was still a very different place. And for all that time, it moved silently through space, across unimaginable distances, unaffected by anything, until finally it reached us. And in that moment, it became knowledge. It became understanding. It became the story. There is something almost gentle about that across such vast time, something can travel uninterrupted just to be seen, just to be noticed. And now, as you sit here listening, you are part of that journey, the endpoint of light that began long before humanity existed. And perhaps that is one of the quiet wonders of the universe, that even across immense distances and immense time, there are connections, subtle, patient, but real. Now, let's allow the final layer to settle in. IC 1101 may be the largest galaxy we have found, or it may simply be the largest we have been able to recognize so far. Either way, it stands as a reminder, not of how much we know, but of how much there is still to discover. Because every time we build a more powerful telescope, every time we look deeper into the sky, we do not reach an edge. We find more galaxies, more structures, more mysteries waiting quietly beyond what we can currently see. And somewhere out there, there may be something even larger, something that makes IC 1101 feel just another step in an endless scale. But for now, this is where we are, at a point in time where we can look out into the universe and begin to understand just a little more than we did before. And that is enough. Let the idea of that vast galaxy remain in your mind, not as something overwhelming, but as something calm, something steady, something that has existed long before us and will continue long after. A quiet giant drifting through the darkness, holding trillions of stars, each one shining in its own time. And as the thought slowly fades, you may notice something else. The universe does not rush. It does not hurry. It simply continues. Now, we drift even further into stillness. At this point, there is nothing new you need to learn. No new numbers to hold on to, no new structures to imagine. Only a quiet awareness of what already is. IC 1101 continues to exist, not as something dramatic, not as something loud, but as something steady, presence more than an event. And if you could somehow move closer to it, not quickly, but slowly, gently, over millions of years, you would not experience a sudden arrival. There would be no clear moment where you cross a boundary and say, "Now I am inside." Instead, the stars would simply begin to feel more numerous. The darkness between them slightly less empty. A gradual transition from intergalactic space into the outer halo of the galaxy. And even there, it would still feel quiet, because the stars in IC 1101 are spread across such enormous distances that even inside the galaxy, vast emptiness remains. You would not see crowded skies. You would not see blazing light everywhere. You would see points of light separated by immense space. A reminder that even the largest structures are mostly emptiness. And yet, within that emptiness, everything exists. Stars, planets, possibly life, all suspended within a structure so large that it no longer feels like a single object, but a region, a slow field of gravity and time. Now imagine drifting further inward. Over millions of years, the density of stars increases. Not suddenly, but gradually. The light becomes slightly more present, slightly more continuous. And eventually you approach the central regions. Here, the motion of stars becomes more complex. Their paths less orderly, shaped by countless past interactions, by the long history of mergers that built this galaxy. And somewhere within this vast inner region, that central black hole remains, invisible, silent, and yet profoundly influential. Stars move in response to it, even if they are far away. Gas flows around it, slowly spiraling inward. Energy is released, not in explosive bursts, but in steady processes unfolding over immense spans of time. But even here, at the heart of something so massive, there is no sense of urgency. no sense of chaos, only motion, continuous, unhurried, inevitable. And this may be one of the most surprising things, that something so immense does not feel violent, feels calm, because at this scale time itself stretches. Events that would seem dramatic on human timescales unfold so slowly that they become almost imperceptible. A galaxy merging takes hundreds of millions of years. A star evolving takes billions. Even the growth of a black hole happens gradually over vast spans of time. So everything, no matter how powerful, becomes gentle. Now, let's step back once more, not physically, but mentally, back to where you are, right now, listening, aware, and consider this: every atom in your body was formed in a star, long before Earth existed, long before the Milky Way fully formed. Those atoms traveled across space, across time, becoming part of new systems, new structures, until eventually they became part of you. So in a very real sense, you are connected to galaxies like IC 1101. Not directly, not in any immediate way, but through the same processes, the same origins, the same cosmic history, and perhaps that is where this journey settles. Not in the size of the galaxy, not in the numbers, but in the quiet realization that everything we have explored is part of the same universe that you are part of, the same laws, the same time, the same unfolding story. Now, as we move into the final segment, there is nothing left to explain, only something left to feel, a gentle closing to a journey that never truly ends. Now, there is nothing left to reach for, no more distance to travel, no more scale to expand, no more questions that need immediate answers, only a quiet awareness of everything we have already touched. IC 1101 still drifts where it has always been, far beyond what we can see with our eyes, far beyond what we can ever physically reach, and yet somehow present here in your mind. A galaxy so large, it reshapes the meaning of size, and yet so calm that it almost disappears into the background of the universe. And maybe that is how the largest things exist, not loudly, not demanding attention, but quietly, steadily holding their place across time. If you imagine it now, you do not need to see every star. You do not need to understand every distance. You can simply imagine a vast field of light slowly fading at the edges, blending into darkness. No sharp boundary, no clear ending, just a gentle transition from something into nothing. And somewhere within that vastness, stars continue to shine, each one unaware of the scale it belongs to, each one simply existing in its own time. And that is enough, because in the end, nothing in the universe needs to know how large it is. Simply is. Now, let your thoughts drift slightly closer, not to the galaxy, but to the idea of time itself. Because everything we have explored has unfolded across billions of years. And yet, to the universe, that span is natural, unhurried, effortless. Galaxies grow, stars form, black holes merge, all without urgency. There is no deadline, no pressure, only process. And in that, there is something deeply calming, because it reminds us that not everything needs to happen quickly. Not everything needs to be understood immediately. Some things are meant to unfold slowly, to be observed gently over time, just like this journey. Now, imagine the light from IC 1101 once more. That long journey across 1 billion years. It did not rush. It did not change direction. It simply moved steadily until it arrived. And now, that same light has become part of your awareness. A connection across time, across space, across unimaginable distance. And perhaps that is what makes this so meaningful. Not the size of the galaxy, but the fact that somehow you are able to know it exists, to imagine it, to feel its presence, even from so far away. And in that moment, the distance feels a little smaller, not physically, but perceptually, because understanding creates a kind of closeness that distance cannot fully erase. Now, as everything begins to settle, you can let go of the details, let go of the numbers, let go of the structure, and simply hold on to the feeling of something vast, quiet, and steady, existing out there beyond everything familiar. A reminder that the universe is not confined to what we can easily see. It extends far beyond, in ways that are both mysterious and peaceful. And as your thoughts slowly drift, you may notice something gentle. The same stillness that exists in distant galaxies can also exist here. In this moment, in this breath, no rush, no urgency, just presence, just awareness, just a quiet connection to something much larger than yourself. And as the idea of IC 1101 fades softly into the background, it does not disappear. It simply becomes part of the wider picture, a single piece in an endless universe, a quiet giant continuing its journey, whether we are watching or not. And maybe that is the final thought to rest with, that the universe does not need to be fully understood to be appreciated. It only needs to be noticed. And tonight, you have noticed something truly immense. So now, let that awareness soften, let it drift, and let the universe continue quietly on its own. If you're still here, gently type 3 in the comments.